Alright, so today's lesson is 3.2, and we are going to look at maxima and minima on an interval. So a specific interval or a specific domain, like between, for example, x equals 1 and x equals 5. We're going to look for the maximum value between those points and the minimum value between those points. So to do that, or to understand how to do that, let's start with a little investigation. Question 1 here says, for the following function, right, 4x squared minus 12x plus 7 on this interval, determine by completing the square, we're jumping back to grade 10, the value of x that produces a maxima or minima. Okay, well this is a quadratic, so we know there's going to be a maxima or minima at the vertex. That's why they want us to complete the square. They want us to find the vertex. In this case, we have a positive a coefficient here. So it's going to open up something like this. Right? And therefore, we're going to have a vertex right there. So that's going to be a minimum. We're going to have a minimum. So let's figure out where that is. If you guys forgot how to complete the square, don't worry. I'll show you. But I'm not going to test you on this in calculus. So here we have f and x equals 4. Let's just pull out that 4 right away for the first two terms. So x squared minus 3x. And then we'll just stick that 7 on the end, and we're going to leave it there for the entire time until the very last step. Okay, so completing the square. So x squared minus 3x. Take negative 3, take half of it, 3 over 2, square that, 9 over 4. And then we'll add 9 over 4. And subtract 9 over 4. And we'll just leave that 7 over there. Alright. So now right there is our perfect square. So we're just going to have x minus 3 over 2 squared, and we still have this negative 9 over 4. Multiply that 4 through. Get 4. X minus 3 halves squared. This works out nicely. 4 times negative 9 over 4, just negative 9 plus 7. And now we can just take that plus 7 finally. X minus 3 halves squared minus 2. Okay, so we get that vertex at x equals 3 halves. So that's where the vertex is. Well, now let's see if we can figure out an easier way of doing that. Instead of completing the square, let's find the derivative of f prime and x. Alright, this is just a polynomial, so we're just going to do a couple power rules. So we get 8x minus 12. That's it. Now, if we look back over here, the tangent at that minimum is going to be horizontal. So horizontal tangent has a slope of 0. So if we set this equal to 0 and solve for x, we get 8x equals 12, or x equals 12 divided by 8, or 3 over 2. Oh my goodness, that was so much less work than completing the square. Didn't you guys love that? Alright, so this shows a couple things. One, it shows that we have a minimum point here. But would that be the absolute minimum point? We can't be completely certain. Let's try another example. We're going to do a cubic example down here. Now in this case, it's a quadratic. So we can sort of say this is going to go up to some value where it's negative 1, and this is going to go up further to some value with its 4. So we can say for certain that's going to be a minimum. The maximum would probably be at one of these 2 points, okay, on the interval. But what if we had a cubic? Now a cubic could look something like this, or like this, or like this. So you can see we have a couple of situations here. We're going to have tangents equaling zeros in 2 locations. Now those tangents could be this could be the maximum, but it might not be, right? The interval or the endpoint could also be the maxima. So let's find the derivative and see what happens. So derivative of f of x, we just got some power rules here. So we have 3x squared minus 6x minus 8. And if we set that equal to 0, unfortunately, you can't factor that very nicely. So you can just use the quadratic formula. So you would have x equals 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 8 all over 2 times 3. All right, and when we put all that into our calculators, we get two options, 2.915 or negative 0.915. All right, so that is actually two possible options. And I have those two options right here. Let me zoom in. So I've graphed that function. So here is our negative 0.15. And here's our 2.915. And you can see this is the maximum point because our intervals or our endpoints have values here and here. And this is also the minimum point. But that's not the only option that could happen. We could have something like this. Now this is a different function, but I just put it in here as an example where your maxima point, I should say like a local maxima. We'll talk more about local maxima when we do curve sketching. But here's a local maxima and a local minima, but it's not the absolute maxima or absolute minima. The endpoints are higher and lower than that. Okay, so to figure everything out then, to figure out what the absolute maxima or minima are, let's do an example problem. All right, so our first example then is find the extreme values, so the absolute maxima and minimas, for this function on this interval. All right, so let's start by finding the derivative and seeing where we have tangents with a slope of 0. So I'm going to write f prime of x will be minus 6x plus 6x squared, sorry, plus 18x. All right, so we're going to set that equal to 0 to find our horizontal tangents. And this I can factor out of negative 6x, which will give me x minus 3, which is equal to 0. So we have two solutions here. X can be 0, and x could be 3. Now both of these solutions, 0 and 3, are on this interval, or inside that domain. So they're both possible absolute maxima or minima. They're definitely local maxima or minima, but I don't quite know yet if they're those extreme values for this function. So what do I have to do then? I have to test them. I have to test the endpoints, and I have to test these local maxima and minima. So to do that, we're just going to plug them back into the equation or into the function. So the function at 0 then, let's test this one. If I put 0 in here, so 0, 0, we're left with 4. Okay, what about 3? Let's do the function at 3. Let's test this one. It's going to be minus 2 times 3 cubed plus 9 times 3 squared plus 4. And if we do all that, we get 31. Okay. Let's test the endpoints. So let's test f at -1. If we test this one, we get -2 times -1 cubed plus 9 times -1 squared plus 4, and we get 15. All right, one more point to test this endpoint, f at 5. So if we test f at 5, we get -2 times 5 cubed plus 9 times 5 squared plus 4, and in that case we get -21. All right, so what is the minimum point? That would be this one right here. That's the lowest point on our graph. All right, so the minimum is at f at 5, which equals -21. And what's our maxima? That would be this point here, which is where one of our slopes was 0. So the maxima is f at 3, which was 31. All right, for this question and the next two questions are application questions, because you can probably see it's very useful, not the situation, to determine min and max values. So this one says the amount of current in amperes in an electrical system is given by this function. C is for current. For those who are in my physics class, we use I, but in this case we're using C, where T is the time in seconds. And we have this interval between 0 and 5 seconds. Determine the times at which the current is at its maxima and minimum. And determine the amount of current in the system at these times. Okay, well, there could be a maxima or minima on these intervals, but there could be one somewhere else. So let's see where we have a tangent of 0. So we're going to start by finding the derivative. So we get minus 3t squared plus 2t plus 21. We're going to set that equal to 0. I'm going to pull a negative out of that, so we're going to get 3t squared minus 2t minus 21 equals 0. Now we can factor this one. 3t plus 7 and t minus 3. So we have two solutions for t. One, it can be -7/3, or t could be 3. But let's look at these two solutions. This one, t equals 3, could be a possible maximum or minimum because it is on the interval that we care about. But this one, -7/3, it's not on that interval. So it's not going to be one of our solutions. I'm going to cross that one out. So that means we have 3 possible solutions to test. Our endpoints, 0, 5, and this horizontal tangent, 3. So let's test all of those. We'll start with 0. That one's easy. So c at 0 equals 0, 0, 0. See, that one's easy. Next we can do 3. So c at 3. Got minus 3 cubed plus 3 squared plus 21 times 3. And we'll get 45 if we do that. Lastly, c at 5. Get minus 5 cubed plus 5 squared plus 21 times 5. And if we do all that, we'll get 5. So it wants to know where our maxima and minima points were. Well, this is our maxima point. So our maxima, so at time equals 3 seconds, our current equals 45 amps. So that's our maxima. And our minima occurred at time 0 seconds. So at time 0 seconds, our current was 0 amps. So there's our maxima and minima values. Right, so our last question says, the amount of light intensity on a point is given by this function, where t is the time in seconds on the domain between 0 and 14 seconds. So that's the interval. And it wants to know the minimum intensity, so just the minimum. We still have to do the same things. So first, we're going to have to find if there are any horizontal tangents. So to do that, we have to find the derivative. And that's going to be a quotient rule. So I prime of t. So let's apply the quotient rule. So first, the derivative of the numerator. So we're going to get 2t plus 2. Multiply that by the denominator, t plus 2. Then we're going to subtract the numerator. Just running out of room. So t squared plus 2t plus 16. Multiply that by the derivative of the denominator, which is just 1. And then divide all that by the denominator squared. So t plus 2 squared. All right, so let's clean this up a bit. So here we'll get 2t squared plus 6t plus 4. And I'll just distribute that negative throughout. So minus t squared minus 2t minus 16, all divided by t plus 2 squared. All right, collect like terms, and we end up with t squared plus 4t minus 12 all over t plus 2 squared. Now we're looking for horizontal tangents, so we're looking where this is going to equal 0. And for that to be true, we really only need to know where that numerator is going to equal 0. So what I want to know is, where does t squared plus 4t minus 12 equals 0? Okay, we can factor this one. So we get t plus 6 and t minus 2 equals 0. So two possible solutions. Either t is negative 6 or t is positive 2. But let's go double check that interval in the questions. The interval was between 0 and 14. 2 is definitely between 0 and 14. But negative 6 is not between 0 and 14, so we do not care about this solution. So to find the minimum then, we need to test in our function 3 values. T equals 2, t equals 0, and t equals 14. So let's try first 0. 0 is an easy one to test. We just get 0, 0, 0. So 16 over 2, we get 8. Now we'll do our horizontal tangent. So I at 2. We'll get 2 squared plus 2 times 2 plus 16 all over 2 plus 2. And that gives us 6. And finally, our other endpoint, 14. So if we test 14, get 14 squared plus 2 times 14 plus 16 all over 14 plus 2. And if we do that, we get 15. So where's our minimum point? There's our lowest value. So therefore, the minimum occurs where t equals 2 seconds and has a value of 6.